We are back in person. Yay! So, woo! Thank you so much. I'm so glad to be here. I always love coming to PyCon UK, so that's really great. So today I'm going to talk about hypothesis, but you can see as the title that actually I am very naughty. I don't like writing tests because but before I start, those are my Twitter handle, whatever. Feel free to take a picture of me, hello, and tag me if you want to. I love pictures. Also there's a link there if you want to get the slides after, or if you want to try out some of the example yourself, or use the link to go to the official documentation page. That's for you. So. I would give you some time to take a picture of this if you want to. Okay, so let's go. For those of you who doesn't like tests, so maybe I should ask this question first. How many of you also like me doesn't like writing tests? Yes, I won't tell your colleague. Yes, okay. Now like some of us doesn't like tests, right? Like but what stops us from writing tests? Why writing tests sometimes is such a painful experience. These are something that come up with me sometimes. First of all, importing the code. I don't know, sometimes I use PyTest. I feel that like PyTest sometimes doesn't understand where the code is, and it's very difficult. So that's one of the things that I don't like about writing tests. The second thing is organizing the tests. Like, when you are working with a big project and have someone has already written a lot of test function, you don't know where to put it, or you found that like very frustrating to find like what test is doing what, right? Sometimes you have a lot of tests, each one of them, because we do unit tests and stuff, right? So each one of them do one little test, and there are millions of them. So it's become messy very, very easily. Another thing I think is quite difficult for me is to think of the test case, because sometimes we have a piece of code or we have an application that is expecting some input, and I don't know what I should test, because if you hand your piece of code to someone else, sometimes unexpected things may happen. People can input whatever they want. Free text. We all experience that. We don't know what we could expect from a free text, So yeah, that's the very difficult thing. I hope that hypothesis could help you with the last two struggles that you have, because I feel your pain, right? I already told you I don't like writing tests, so can hypothesis help you with that? Hello, I'm Cheuk. Right now I work for Anaconda as a developer advocate. So if you're a data scientist, hello, I'm here. So talk to me. Or if you have been to the talk about PyScript and interested in PyScript, also talk to me. So I have been involved in different open source projects. I love open source. That's why I love telling people about different projects. I also organize different events, so I will tell you about one of them at the end of the talk. But I love seeing all of you. And I also stream on Twitch a little bit during the pandemic because I got too bored. So have you heard of something called the property-based testing? I see some no, some yes, some hands up, very confident, yes. Just so all of us are on the same page, I'm going to, make some little knowledge about what is a property-based testing. So to compare property-based testing and what we do normally, quote unquote, which I would call that by test by example. So test by property is that you would give, you're giving something that's quite obvious, because who do typing of your code? Who is using the typing? Yes, some of you, yes. So when you do typing, you already know what type of input you're expecting, right? Sometimes it's more than one of them, but you will list it out. So it's quite obvious that what is given. So that's something that kind of match with property-based testing. If you test by example, the contrary, you have to think of what is and what is not. So even something very simple, right? So you're testing all the integers. So it's an integer. So if you say integer, it's very obvious. But if you test by example, so you have to think about, okay, what integer? Do I test 0? Do I test 1? Do I test minus? Do I test very big integer? Or do I test very small integer? So you have to think, right? So that's the difficult bit of writing tests. Also, yeah, like I said, property-based testing actually works very, very well if you already type your code. There's some magic at the end that I'm going to show you. If you type your code, actually, it will work very well with hypothesis. If you test by example, you have to think about what is the example. Like I said, testing integer, what should I test? If I test a string, should I test a string that's super long? Should I test a string that's empty? Should I test a string that is actually all digits? So it's not that straightforward and simple. And then the good thing about property-based testing is that with the right strategy, all the edge case will be found automatically. So you don't have to think about what I just mentioned. Do I test the 0? Do I test the empty string? All those like so-called edge cases. Some of them are very obvious, like the one that I just said is, I think it's very straightforward that, 0 may be something very special. But sometimes the edge case is not easy to find. Sometimes someone just very busy, or you have to quickly ship the code, and you forgot to test the edge cases, which is always where people found bugs. We have all been to the keynote today and know that sometimes if you don't test your code properly, awful things will happen. So how does hypothesis do it? It sounds like magic, right? So when we use hypothesis, we have all these things that is called decorators. We all know what is decorators, I hope. So, but if you haven't, I will show you what a decorator look like in a bit. So the decorators act like an entry point to modify the test. So there are some decorators that is provided by hypothesis. So we just pull them and then put them in the test function, and then they would modify the test for you. So if you have used PyTest parameterized, it's kind of like that, but better. So also, hypothesis, there are strategies. There are already some built-in strategy for you, so making all these things a little bit easier. So it will generate the test data with the strategy. Of course, you can have your custom strategy. If you are testing something very, very unique, that you think, let's say I'm testing only the prime numbers, let's say, then you have to write your own strategy to generate all the prime numbers. But otherwise, all the common stuff, like if it's just an integer or a positive integer or a string and or a number and all this stuff, the strategies are there for you to use. So this is the 101 example on the documentation website. I hope you can see the first line, because I highlighted it. So now we have two functions here, right? So, I'd only highlight the outside, like just the declaration of the function, because don't worry too much about how they work. I'm just going to show you that there's actually two functions here in the code. There's encode and decode. So encode and decode, what it does is what the name is. They just encode and decode. This example is from another project. I forgot the name, but you can check the documentation if you are interested. So this is the whole code. So it's very straightforward, very simple. But I want to show you how we can test it. So this is how you write hypothesis. I hope it's still big enough, but I will show you the code in my editor in a bit, so I can zoom in if it's not big enough for you. So hypothesis. Again, remember we have two things, right? We have decorator and strategy. So we have two things here. The given is the decorator that is provided by hypothesis. And then we have the strategy. And this time we use text, which we are expecting the input to be a text, because we are encoding and decoding text. So here it is. And I used the decorator. So this is how a decorator looks like if you haven't used decorator before. So this is with the add and then the name, and then sometimes you have the input for the decorator, just like that. So with this, so we use the given decorator and we put the strategy there, which is the test inside. And then this is how the whole test look like. It's only how many? 5 lines of code. Don't count the empty ones, so 5 lines of code. So you see that we have generated the test, and then it will be called as S in the test function, and then we'll check whether we encode it and decode it will be back to itself. Very simple, right? So let's do that real life to see if it works. So this is the code. I have zoomed in. I hope it's big enough for you. This is the code, and this is the test. So exactly the same thing, except that I have to, of course, import the code because it's not in the same file. So let's test it. So PyTest, test Py. Okay, let's run it. Ooh, something's wrong. Yeah, it's a bit difficult to see, so I will just tell you what's going on. So the test actually found something doesn't work. When the string is an empty string, it won't work. So it found an edge case for us. So in this code snippet, actually there's it's a very small function, but it misses one thing. That what if the input is empty? Then it won't work. So that's great. That's what hypothesis is doing. So this is, again, this is a 101 example on the documentation website. You can go there and find out yourself if you want to test it or read into the details. So that's hypothesis. That's the very, very basic of hypothesis. But today, I want to also introduce you to one very amazing thing that hypothesis provide, is that what if I'm very, very, very lazy? Even writing a few lines of code and writing one test is too much for me. So in this case, there's another thing that can help you. It's even better if you already done typing. So I hope that you're lazy, but not too lazy to do typing. Because I'm going to introduce you with a new tool that's called Ghostwriter. So they are writers that write tests for you. So yeah. So what it would do is that, for example, you have a module, so the input can be a module, can be a class, can be a function. So you give that to hypothesis. There's a CLI tool which I will show you. So you give that, and then the ghostwriter will write the test for you, which based on the typing that you use. So it will pick the right strategy because when you do the typing, like I said, you already labeled what type of input you're expecting. So the ghost typewriter will look for it and then say, oh, you are expecting an integer, so maybe it should be a number or an integer. If it's a string, then maybe it's a text. So it will do that. So like I said, there's a CLI tool. We're going to use it in a bit to see how it works. Also, if you have Black installed, it will black the code for you. So for those of you who love Black and can't code without Black, yay. So far, we have mainly 4 ghostwriters available. There's actually more than 4, but I will only introduce 4 to you because those are the ones that are more commonly used. But all of them, again, is in the documentation page. So the first one is fuzz. So it will just check whether your function will lead to some expected expectations. So this is an example here. So this is quite widely used because in your application or module, sometimes it would just raise some exception. So it would just check whether the exception is raised. If not, then everything is fine and all that stuff. So it would generate that test for you. The other thing, this is the interesting one in my opinion, because it is checking whether the same function is called twice and the result doesn't change. What does it mean? Is that, for example, you have a sort function. If you have a list that you need to be sort, so it got sort once, it is sorted. So if you call it twice, it actually doesn't change anything. So this is what it's checking. It's checking whether you call sort once and call sort twice, are they different? If it's different, then something's wrong, right? Because, well, you're supposed to finish the job the first time, and why calling the second time will change things, right? So this is an example here that you have a sort function. Then you can use the ghost typewriter to generate the test for you. And the So this is the one that is also very commonly used. It's called round trip, but it's not testing one function. Usually it tests a pair of functions. So for this one, the ghostwriter will look at your module. So usually you don't put it one function, you put a module in it. So you look into the module to see if there's a pair of functions that actually go round trip, like the encoding and decoding that we have before. So the most common example that is already in your C Python distribution is in the JSON library, which is JSON dumps and JSON lows, or JSON dump and JSON low. They come in a pair. Other thing that, for example, if you name two functions, one is called to dictionary, the other is like from dictionary. Of course, they are again a pair, or to JSON from JSON, they are a pair. So those actually, the ghostwriter will pick it up and know that, oh, that's a pair. So I can do the round trip test to see if I call the first one and then call the second one, it will go back to original result. So that's what it does. And there is the equivalent. So equivalent is, you can't just check it with one function. You check it with two functions that they're doing the same thing. It's useful when you are implementing another function that do the same thing, but maybe faster, more efficient. You want to check that they actually, check it against something that it works. So let's say you have a sorting algorithm, and then you want to check it against the one provided by CPython, whether they are correct. So the one in CPython probably is correct, because if it's not correct, then we have been using it for years. So I want to check whether mine is correct, so I can check it against that one. So here you can see that I write a power function. I check it against the one in the mathematical library. But this one will actually give you. This one actually doesn't work because the one that I've written is wrong. So if you use this, you would be able to check it. So those are the four major ones that I talk about, and there's actually two more. Just to give you an idea, they are the binary operations for testing binary operations that you define. So it's custom-defined binary operations, or UFung if you are using NumPy array. So there's actually a lot of things in hypothesis support NumPy arrays, or NumPy in general. I'm currently working on an issue to do some typing thing with NumPy typing, so fun time. So yeah, if you're doing scientific programming, actually hypothesis can help you as well. So this is how you use the CLI tool if you have hypothesis installed. I think you have to install it with the bracket CLI option, or install click separately, but if you have installed everything, this is how you use it. Hypothesis write, and then the name of the module or the function. You can try it with the standard library ones because they are there. So you can, let's say, hypothesis type JSON, it will be there. But I think it's better if I show you than telling you. So hypothesis. So maybe I clear it. Wait a second. Let me clear this. OK. Hypothesis, I want to write, right? There's a S, right? There's no S, OK. I have my cheat sheet with me. So I have the myco.py, right? So it won't work because it should not have .py. Yes. So this is the ghostwriter generate this file for me. So imagine I haven't write the test, right? So now hypothesis will just generate this for me. And you can see that I have a given. It's very similar to what I have done. So so what it does is that it will get given as the decorator. It will get the strategy. So it's using the text strategy here in the given. You can see that in the thing. And then it's doing I think it's doing the round trip test. Yeah, it's doing the round trip test, I think. Yeah. So it's generated a test for you. If you don't like it, you can change it, of course. But so what you can do is you can do this, right? And then you can just put it in a file. Test2, I don't know. Can I do this? And then now I have the other file. So now I can run this test if I want. So I can do PyTest. Okay, so test 2. Yes. Yeah, it will give me also the same error. So I don't even have to write the test, and I can just use the typewriter, generate the test, and then run the test. And then it will give me also the same thing. That's saying like it's not working. So this is the ultimate lazy way of doing it. or if you're interested, I think I have time to show you. I'm now too excited. So, but why I'm okay. Right. Yeah, if you run on the, so this is the whole JSON module, JSON standard library there. It will test everything, so you can test the JSON module if you want. And also one thing, sometimes the ghostwriter will give you st.nothing. So that means that you have to provide your own strategy because the ghostwriter is not smart enough to find the right strategy, sometimes because you don't type it very solidly. That's why it doesn't know. But most of the time, if it's small, if you have typed it, then it works properly. So there's a little caveat before I end the talk, because why there isn't many people using hypothesis yet. So I'm trying to address this. So before you use hypothesis, you kind of have an idea that this may not work for you. Sometimes tests can run slower because hypothesis is generating all this strategy for you. So instead of you putting let's say 10 examples or 5 examples, hypothesis need to find the example for you. So that's why it could be slower if you have very complex things. Tests can be hard to understand because instead of looking at the example, you kind of have to digest the bug report, the bug report, like the thing the PyTest tell you something's wrong, then you have to digest it. It's like which one went wrong, which example failed, so you have to digest that. So yeah, the ghostwriter is very, very nice, as you can see. But if you're very, very lazy, if you don't type your code, then there will be a lot of st.nothing, so you have to fix them all. So it's not very good if you're too lazy. So that's the end of the talk. But before that, I got to tell you one conference that I'm organizing. It's an online conference. It's at the end of November. And CFP is open. So if you like to give a talk and you want to give it online, so this is a very good chance to do it. So. That's it.